Hey ocean travelers around the world. This is the Kraken. From sailor's terror to science's giant reveal. From fear-soaked logbooks to deep-sea cameras. The Kraken moves from legend to living biology. Tonight, every clue gets tested, and a modern portrait finally comes into focus. A ship crosses a pale blue reach of northern water, with gulls trailing far behind. The morning feels unhurried. A lookout rests his hands on the rim of the crosstree and scans the glassy patch ahead. The first sign is nothing dramatic, only a wrinkle where no breeze should make one. He calls to the deck that the surface looks as if a chest is breathing beneath it. The helmsman makes a small correction to keep the bow on course. Then something smooth passes along the hull, not a bump like wood or a rope, but a living press, soft and firm together. Just under the paint, lines shiver. A coil near the foremast slides 2 inches and stops. A crewman kneels and touches the waterline. His hand rises with the faint smell of ammonia. Minutes later, when the light leans differently across the planks, round impressions appear where the contact lingered. Circles the size of small plates, arranged in tidy rows, each with a delicate rim that looks almost toothed. The log for the day written after breakfast is calm. Light airs, fair sea, brief contact of unknown animal, round marks at the forefoot, no damage. There are no exclamation points and no talk of monsters, only measurements and the slight puzzle of circles. That measured puzzle sets 3 questions that steer the rest of the voyage. First, what did witnesses actually see and feel? Ripples without wind, a soft weight sliding, the smell like a bottle of cleaner, and round marks that seem stamped rather than scratched. Second, what living creature can produce those signs with ordinary parts? Eyes, arms, suckers, beaks, no magic at all. Third, how can modern tools capture the same kind of event as evidence anyone can check? A clear image close enough to read anatomy, a water sample with a species signature, and a match between marks and known suction rings. The answers live in 4 steady kinds of proof. Whales that wear circles as scars, beaks and tentacle clubs that reach beaches or nets after storms, at-sea footage that shows arms, clubs, fins and eyes under gentle lights, and genetic traces that confirm identity from a sip of seawater. Step by step, these proofs turn a shape in a sailor's mind into a living profile. Before you get comfortable, take a moment to like the video and subscribe, but only if you really enjoy and want to fall asleep with ocean stories whenever you want. The working meaning of Kraken in this calm examination is precise and testable. It refers to very large, deep ocean squids, chiefly the giant squid and the colossal squid, and to the real signs they leave behind. No thunder is required. These animals own some of the largest eyes of any living creature, eyes made to gather faint whispers of light. Along their arms sit suckers rimmed with stiff, serrated rings that can grip like careful tools and leave clean circles when they let go under tension. 2 longer feeding tentacles end in clubs that snap forward to catch prey and then pull it inward. Hidden under the crown of arms, a sharp beak cuts through fish and other squids, and that beak, the hardest part, resists decay long after storms, erase everything soft. When a notebook speaks of ropes brushing a hull, when a hull displays round paired marks, when a whale surfaces with a forehead printed in circles, these signatures explain the scene without reaching for fantasy. A quick reality check places a promise on Nidant's table. Every legendary behavior will face a modern mechanism. A ship held fast? Numbers of force and leverage will answer that. A many-armed island? The human eye's habit of merging separate shapes on moving water will be brought in. A pale gaze from the deep? The physics of large pupils and reflected light will take that role. The purpose is not to shrink the wonder. The purpose is to give it names, sizes, and motions that anyone, children, deckhands, and professors can follow together, like a museum guide who shows a drawer of beaks and says, "Here is the truth," and it is plenty. The word Kraken walks out of old northern pages with salt on its boots. In Icelandic and Norwegian writing, the sea is a road and a workplace, and it is also opinionated. Early accounts describe something so broad it could be mistaken for an island, and so changeable that it rises and sinks without warning. One chronicler calls a patch of ocean boiling, though the air was still. Another calls a sudden lifting of water a hill where there should be none. Sailors who navigated by star, smell, and stubborn practice were honest observers. They knew the shapes of whales, the slap of a tail, the roll of porpoises, and the way kelp gathers like rafts. When they wrote of many branches reaching and then falling, they meant exactly that. Multiple lines shifting in rhythm, not a single spine. Their repeated motifs, boiling water, many arms, ships that lost way, are not proof of fantasy. They are hints that a real builder of circles lives below a layer of myth. Fog, distance, and fatigue work quietly on memory. A gray morning softens outlines. A swell raises and lowers a point of view by a meter or two. What is 10 meters long and 30 meters away by one pair of eyes becomes twice a mast at the dockside. A week later, none of this makes a crew untrustworthy. It makes them human. A warm, careful reading of old notes gives those witnesses respect while translating their words into steady causes. Prey fish churned by a hunt under them, long tentacles lifted like pale cables, a crown of arms exploring, a beak that never breaks the surface, and a mantle that rises like the shoulder of a swimmer and then vanishes as if folded into the water. Drawings gave the world its first photographs of sea monsters, and drawings also gave those monsters teeth in the wrong places. Marginal sketches in bestiaries stretched tentacles into forests, turned suckers into giant eyes, and crowned heads with horned helmets, because horned helmets were already on the shelf in the print shop. Yet a few artists, whether by luck or by listening well, carried truths forward. Some placed a beak under the arms where it belongs. Others showed suckers in neat rows instead of random wart-like bumps. Woodcuts showed fin-like lobes on a mantle just where anatomy places fins. Street songs and ballads did their part too, keeping a curved beak and a tangle of ropes alive in the ear. Culture exaggerated the scale and the drama, but culture also protected a few correct features that matched the real animals closely. The anatomy that sits under those features is straightforward and elegant. A giant squid's mantle is a sturdy, flexible tube where the main organs live. A funnel beneath the head serves as a jet nozzle. Water goes in, water jets out, and the animal moves the other way. A pair of thin fins undulates near the mantle's end, adding gentle steering and hover control. 8 arms reach out around the mouth like thick fingers, each lined with rings of suction cups. 2 longer tentacles, leaner, like elastic whips, extend beyond the arms and end in clubs. Those clubs carry larger suckers arranged to grab and hold. The beak, tucked under the arms, works like a curved knife. Inside the beak, a radula, think of a belt, with teeth, pulls food in. Muscles in the arms and tentacles work without bones. They stiffen, bend, and twist because their fibers run in layered grids. A trick called a muscular hydrostat. Signals race along giant nerve axons, the famous thick fibers that let a squid coordinate a quick jet escape or a sudden strike. Watch out for this. That single engineering set jet, fins, arms, clubs, beak can explain almost every surface sign that filled old pages. 2 long tentacles brushing a hull feel like ropes. Sucker rings leave circles. A hovering mantle makes a hump with no fin. A jet makes a starburst wake instead of a single trail. A second heavyweight shares the stage. The colossal squid differs not by pure size alone, but by build and tools. It is stockier relative to its length. Some arm and tentacle suckers carry swiveling hooks rather than only serrated rings, better for holding prey in cold, turbulent water. Its eyes, extraordinary among animals, help in zones where light is a rumor. Where the giant squid often belongs in North Atlantic and North Pacific stories, the colossal prefers southern waters, where ice lines act like moving coastlines. The differences matter when reading reports. A heavier, slower, hook-armed animal that rises with a firm presence and does not chase long distances fits the colossal's file. A sleeker animal with more streamlined runs and classic sucker rings matches the giant's file. Neither needs to be called a monster to earn attention. Whales provide testimony no rumor can touch. Sperm whales carry circular sucker scars across their heads. Fresh scars are pale and clean. Older ones silver into the skin. The pattern of circles, sizes, spacing, paired arrangement matches the arms of large squids. In stomachs, beaks collect like black, curved stones that no digestion dissolves. Size classes of beaks tell scientists how large the squids were, and quietly, how often whales met them. When whales from different oceans wear the same rings and carry the same sizes of beaks, the ledger looks honest. Giant squids and their cousins are common enough to feed whales across basins. The whales' bodies become moving notebooks that say, without metaphors, these meetings happen. They happen a lot. Beaches and decks add their pages to the file. After storms, ribbons of pale flesh that smell faintly like cleaning fluid wash ashore. Clear cases are easy to read. Arm sections with neat rows of suckers and hard rings still attached. Mantelpieces with little pigmented dots that can still open and close like shutters. Tentacle clubs with sucker patterns distinct from the arms. Misleading cases also occur. Decaying whale tissue can fall into strings that look like tentacles. Kelp can wrap on a branch and imitate a limb in photo. Calm shoreline forensics keeps the catalog clean. Measure ring diameters. Photograph rows against a ruler or a coin. If allowed, swab a surface for a drop of seawater that carries environmental DNA. A small sample in a small tube can answer a large argument. The deep itself shapes the animal's look and habits. Below the sunlit layer, the mesopelagic and bathypelagic zones are colder and darker. Pressure increases, oxygen can thin, and light becomes brief flashes, sent by organisms that use it to signal, distract, or lure. In this environment, paler or reddish bodies help with camouflage. Movements use energy sparingly. Eyes grow large to notice silhouettes from far away. When an animal built for this dim room rises toward the surface, it can seem slow or unsure, especially at night, and that behavior can surprise a crew. A calm note helps. Odd, near-surface behavior does not imply intent. It often means a visitor is out of its comfort zone. Finding a giant without disturbing it takes patience and gentle engineering. Baited frames. Release small scent plumes. Red or very low light cameras. Watch without blinding. Motion triggers. Wait for the right pattern of movement. A successful recording shows more than a flash. It offers a steady approach. Clubs opening and closing. A beak glimpsed under arms. A fin giving a slight even wave. A mantle pulsing as a hover is maintained. The best clips capture scale by design, a known plate or bar in frame, so future viewers don't have to guess. Quick fact: in the most useful videos, the animal looks unhurried. Calm behavior gives clean anatomy. Clean anatomy gives confident identification. Footage that softened the debate did not need thunder. It showed arms greeting a bait bag, like careful hands. It showed the round rim of a sucker, where light picked a circle from the dark. It showed tentacle clubs unfolding, like a pocket fan, pressing, and then folding again. It showed the mantle's edge sliding like silk past a fixed camera. Each second in clear water, under gentle light, replaced an entire drawer of arguments. Angle mattered. Straight-on views of clubs revealed the layout of suckers in a way oblique views never could. Distance mattered. A half-meter too far, and the serrations along a ring blurred into a pale smudge. A half-meter closer, and individual teeth could be counted. In this new library, many legendary sentences found honest images to stand beside them. The giants live beyond northern stories. They trace broad paths wherever currents feed and canyons climb. In the Pacific, trenches and seamouths give structure to the water and focus food the way hills focus clouds. In the Southern Ocean, The line where ice meets open water acts like a shelf, lifting nutrients and stirring fish. In subarctic gyres, edges where water masses rub against each other become lanes of life. When strandings cluster, they often line up with these hidden geographies, places where a tired animal might drift toward shore, where a current might turn, or where a shelf edge lies like a cautious hand under a wide sea. At sea, length grows in the mind, because measuring is hard. An observer at night is lifted and dropped by swell. 2 meters feels like 4 when a pale arm glides through a beam and vanishes. Fog steals edges and makes a single long back out of a line of separate animals. The brain is efficient. It likes one story more than many moving parts. A calm practice helps break a moment into elements. A pale line rose here, one there. The distance between them felt like the length of a longboat. Both sank in the same second. That kind of sentence travels better than a massive, many-armed body surrounded the ship. And it teaches children how to watch water wisely. The round marks that opened the voyage return now as a little masterclass. Suction cups grip by making pressure inside the cup lower than the pressure outside. Serrated rings around the rim. Tiny hard teeth dig into softer surfaces, increasing hold. When a sucker slides while it lets go, those teeth carve a clean circle in whale skin and polish a circle in paint. On some squids, especially the colossal, hooks add a different sort of mark. Small punctures or tears rather than smooth rings. Patterns tell tales. Even spacing in a line matches rows on arms. A sudden change in spacing suggests a tentacle club, where larger suckers sit farther apart. Holes, whales, and even a wooden crate can carry those circles like fingerprints. The subject of intelligence steps in without theatrics. Cephalopods learn. In tanks, octopuses open jars and remember routes. Cuttlefish match backgrounds quickly. Squids coordinate schooling and change color in waves across their skin. Distributed control helps. Nerve centers in the arms handle local details, while a central brain manages overall motion. That design suits a place where visibility is short and choices must be made in a heartbeat. Intelligence here does not mean plotting against ships. It shows up as curiosity about lights and cameras, as quick experiments with touch, press, release, press again, and as an ability to adapt when a fish escapes or a current shifts. Growth from hatchling to heavyweight follows a curve drawn by food and time. A tiny squidlet rides the nightly ladder of life, rising toward plankton-rich waters and sinking by dawn. With meals, it adds muscle, length, and confidence. The path to giant seems fast compared to whales and sharks. Many large squids likely live only a few years, growing hard and strong, reproducing, and then dimming. Spawning grounds remain largely unknown, a reminder that even with satellites overhead, the ocean keeps beginnings private. When giants visit shallower layers, it can be because prey rose with them, because illness brought them too high, or because a boundary layer, like a river of food, happened to pass overhead. Hunting style can be read from shape, like handwriting. A sleek body, with relatively larger fins and lighter arm armor hints at more active pursuit. A heavier, hook-armed build suits ambush and holding power. Beak size and shape whisper what kind of prey is preferred. Soft-bodied squid, muscular fish, or armored creatures. Energy math decides the plan. Chasing costs more when water pushes back. Waiting costs more when prey is scarce. Canyons where currents bunch food act like cafeterias. There, even a patient hunter can eat often. On flats where prey spread thinly, fast swimmers do better. In both cases, the picture repeats. A stillness that is not sleep. Eyes open, arms gently pitched, fins making tiny strokes as the animal awaits a change in light that means now. Habitats worth attention share 3 traits: structure below, gradients above, and traffic through. Seamounts push deep water upward, creating stairs of life. Shelf breaks pull currents along edges, like wind on a ridge. Convergence zones gather floating things, from plankton to jellyfish to small fish. And what gathers draws what hunts. A nautical chart shows soundings and lines. An ocean map in a biologist's head shows canyons as streets, fronts as avenues, and seamounts as plazas. Predicting where giants move becomes less like guessing and more like reading city plans in the dark. A modern toolset bridges reading and seeing. Environmental DNA, eDNA, collects a species' fingerprints from a bottle of water. Passive acoustics listens to whales as they hunt because whales point to giants as surely as gulls point to fish. Machine vision finds arm motions and sucker rows in hours of video in which human eyes would grow tired. Put these together and a quiet net forms. A water sample says someone was here. A hydrophone says whales are feeding now. And a camera adds arms arrived at 02. Cross-checked. The three lines of evidence keep each other honest. A favorite question floats up with a smile. Can a squid sink a ship? Gentle physics answers. A ship's freeboard keeps its deck high above the waterline. For an arm to pull a rail down, much of the animal would need to work at the surface, where it is lighter and clumsier. Suction requires smooth contact and loses power over angles. The combined force of many suckers is impressive on prey of similar size, but it falls far short of the energy needed to overcome the buoyancy and inertia of tons of engineered hull. Real interactions look like curiosity, nuisance, and accidental entanglement, not conquest. The giants are strong, the ocean is stronger. Case studies make this plain in a friendly way. A coastal trawler raises a net at dawn and finds two sucker rings stuck to a seam. The skipper presses with a thumb, feels the grip, and works them loose with a spoon handle. A photo is taken with a coin for scale. Measured later, the rings match a known species. A sailboat at anchor records a brief night visit. A pale line glides past a transom light, reaches and slides away. The crew finds faint circles at the waterline in the morning. A lab checks eDNA from a bottle dipped near the same spot and confirms a giant squid's genetic signature. None of these moments belongs on a theater poster. All of them belong in a ledger that turns mystery into map. Culture shaped expectations and sometimes misled eyes. Etchings turn tentacles into forests. Films taught audiences to expect a violent thrash, when a calmer, exploratory touch is more typical, near the surface. Yet culture also preserved right details for the next generation to use well. Children who see a museum model with suckers in exact rows will grow up to recognize that pattern when a camera shows it for a second. A book that draws the beak tucked beneath arms prepares a future witness to say, the mouth is underneath instead of, it smiled with teeth. Teaching the Kraken responsibly means keeping the music of the legend while tuning the instrument to the right notes. Ecology ties the giants to neighbors. They are not kings standing alone. They are middle links in a chain reaching from drifting plankton to great whales. Every night small animals ride a vertical migration upward, and every dawn they fall. Giants eat part of that moving tide. Whales eat giants. Whales breathe, dive, and fertilize the surface in subtle ways that help plankton bloom. When a squid dies, its body falls, feeding creatures on the seafloor that may never see sunlight at all. Fisheries cross these webs. Bycatch sometimes brings up arm pieces. Gear can be adjusted to reduce harm. Reports that include measurements and simple photos help science without adding pressure to sensitive places. Field ethics sit quietly on the deck beside the gear. Retrieval has a place when something already lies ashore or comes up dead. Observation is best when life is present. Coordinates that might expose breeding spots are shared with care. Crews who meet arms by accident are encouraged to release and record. A few simple tools on small boats, marked boards, red lights, a reusable sample bottle, turn chance into data. Shared forms help, guiding notes toward direction, distance, and order of events, not adjectives. A community with those habits becomes a partner in discovery. Ocean change circles back, not to alarm, but to context. Warmer surface layers, sometimes cap the deep, like a lid, shifting where oxygen thins and where prey gather. Giants adjust by following edges where conditions suit. In some regions, eDNA signals appear at slightly different depths than a decade ago. In others, strandings move on the calendar. These shifts are slow enough for careful eyes to track, fast enough to notice across a lifetime. They make a strong case for long, patient records, logs kept by boats, notebooks kept by beach walkers, and time series kept by acoustic stations. Lookalikes deserve clean labels. Oarfish, long and ribbon-like with a crest, rise to die and look dramatic in good light. They are not squids, but in fog they can be misread as pale arms. Jellyfish blooms stretch in currents like scarves and seem to reach when they merely drift. Kelp rafts wrap under a hull and tug lines like a living hand. Whale fins seen at odd angles under gray skies can pretend to be anything for a second. Separation is simple: muscle versus drift, rows of true rings versus smooth tissue, controlled motion versus aimless travel. A child can learn it in an afternoon at a pier. Senses in the abyss close the circle. Large eyes watch for tiny contrasts. Arms taste and touch. Mechanosensory hairs along suckers read small changes in pressure and flow. A camera scene that shows a tentacle club pressing and then releasing a bait bag is not a monster feeding. It is an animal asking a question and deciding the answer isn't worth the risk. Lures that respect these senses, dim, slow, scented, collect better footage than bright, noisy ones. In recordings where the animal feels undisturbed, behavior looks like normal life, which is exactly what science wants. The engineering of a giant can be put into friendly numbers. A tentacle span can cover the width of a small car. A beak's bite is strong enough to slice heavy fish, not to cut steel. The suction area of many cups together can hold a body of similar scale firmly. It cannot keep a vessel from riding a swell. These numbers give boundaries. Inside them, wonder lives comfortably. Outside them, pictures on posters take over, and those pictures do not carry the same respect for truth. Education turns fear into attention, if it is hands-on. A sturdy replica beak that children can open shows how edges meet like scissors. A magnified model of a sucker ring reveals serrations that make perfect circles in soft skin. A hull board rubbed with charcoal over faint rings shows patterns to the fingertips. A dim display with a giant eye model and a single point of light across the room shows why such an eye would grow so large. It makes dim things legible. A calm guide says, this is how sailors saw circles. This is how whales earned theirs. This is how cameras show them today. Questions arrive, and they are welcome. Do the giants rush lights? Bright white beams often startle them, or send them away. Soft red glows seem to be tolerated longer by many deep animals. How deep do they live? Most spend time from a few hundred meters down to around 1,000 or more, visiting higher layers when prey rises or when disturbance brings them up. Why are they rarely seen? Because the deep is big, dark, and quiet, and because encounters are brief, unless a patient tool waits. Are they dangerous to divers? Any large wild animal can be dangerous if cornered or entangled. Risk with giants most often comes from nets, not from intent. The tiers of evidence settle into a simple ladder. Top tier: direct images of living animals behaving naturally, close enough to read clubs, ring rows, and eyes. Middle tier: remains in context, beaks in whale stomachs, arm pieces with rings intact, mantle sections with skin patterning. Base tier: indirect signs, whale scars, hull circles, eDNA that whispers a giant passed through. Any tier alone suggests tiers together persuade. A place with strong whale feeding sounds, clean eDNA hits, and a patient camera that records an approach moves from rumor toward map. Now the modern portrait begins to assemble without fanfare. Scars explain the circles, beaks explain meals, clubs explain the ropes, eyes explain the pale glint, ammonia explains the smell, eDNA confirms presence. Canyons and surmounts explain where, whale paths explain when. The giant reveal is not a drum roll. It is a neat summing up, a sleek hunter that hovers and strikes, a heavier cousin that waits and holds, both wearing bodies designed for a blue night, where light is precious and waste is rare. Pop culture images of ships wrapped like gifts dissolve politely. What remains is a better story, an animal that fits its place so well that it fooled storytellers for centuries, simply because most people live too close to shore. The portrait settles in, and the story broadens from a single animal to the many quiet ways people meet it. A weather log from a small research schooner notes a moonless night with steady swell and a gentle wind that barely tips the masthead pennant. Crew on deck place a baited camera at the edge of a canyon, where the bottom drops from a broad shelf into deeper water. The line pays out slowly, hand over hand, until the rig hangs in stillness. Hours pass. A pale arm arrives first, motion like a ribbon in a slow current. It does not slap, it explores. The club at the end opens slightly like a hand, presses once, releases, then presses again as if a question is being asked and answered. A second arm joins from below. The faint glow of the eye does not come from light inside the animal, but from the way soft illumination treats a wide curved surface. Fins at the mantle give a tiny wave that marks the animal's calm balance. The camera records the spacing of suckers along the near arm. Later on deck, a student uses a simple ruler on the screen and checks those distances against catalogued specimen measurements. The pattern lines up with known rows. A bottle sample taken at the same depth carries a genetic trace that matches the image. The night leaves nothing sensational and everything useful, an identity, an approach, and a place on the map where currents and canyons meet. Another night tells an equally important story by staying quiet. The same canyon, a different tide. The same rig, a different drift. The bait bag ripples, and small fish make fast darts, but only one distant line of motion crosses the frame before darkness takes the scene back. The eDNA sample still holds faint signatures. Someone passed through, but the passive recorder placed nearby hears whales hunting a kilometer away, instead of overhead. The ledger gains a page labeled "No Visitors," light traffic, and that page matters. It says the spot breathes in rhythms larger than any one night, set by food rising and falling in layers and by whales choosing lanes according to those unseen rivers. A fisherman's tidy notebook adds a new detail that anyone can follow. Near dawn, a taut line slackens in a smooth slide, then tightens hard for 2 heartbeats, then falls slack again. When the net surfaces, 2 intact sucker rings cling to a seam. He presses a thumb to the first, feels the seal, and pries it loose with a spoon handle. Back on deck, he places both rings on a scale board and snaps a photograph with a coin for reference. In a small lab later that day, a technician sets each ring under a lens and counts serrations. The count and the diameter align with a known species. The photo joins its coordinates and the date. When a regional map is drawn a year later, that small snapshot anchors a dot with more confidence than a dozen messages that only say something big was here. On a different coast, a beachcomber spots a long, ribbon-like strip of tissue and a hard, shiny edge that gleams like black glass. The strip smells faintly of ammonia. Faint round impressions march along one side in even intervals. A short phone call connects the find with a local lab, where a swab of seawater is taken from the strip's surface. Days later, the lab confirms a giant squid's DNA in that sample. No one in that moment saw tentacles in motion, but the evidence chain is solid: pattern, scent, structure, and a genetic signature. The beachcomber's careful photo and the vial's tiny cargo contribute to a larger picture without drama. With these quiet encounters in place, the script can translate old phrases precisely. The sea boiled, though the air was still. Become small fish corralled near the surface by a hunter below. Viewed from a deck, The pattern reads as bumps without wind. Branches reached around the boat becomes two long tentacles and several shorter arms exploring with suckers, sometimes tasting lines and seams with a gentle pull. An island that sank becomes a mantle, rising under a wave as an animal pauses, then slipping back with water folding over it, leaving no dorsal fin or splash to mark the moment. Eyes like lamps becomes a large pupil rim, catching a beam in low light and returning a curved glint. Discs the size of plates become sucker rings that are at the largest sizes, truly as wide as a hand or more. Nothing in that translation belittles past reporters. It simply gives their words modern names that a school child can hold and a marine biologist can measure. Let's go step by step through the parts that make those moments work. A suction cup grips by lowering pressure inside the cup compared to the water outside. Stiff keratin-like rings around the rim. Tiny teeth aligned in a circle bite lightly into softer surfaces to improve seal and traction. If a sucker pulls away at an angle, those serrations skate for a millisecond, carving a clean ring on skin or polishing a ring on painted wood. On whales which scar easily, the circles remain crisp. On hulls where paint can vary, the circles may appear as bright, slightly smoother rings amid weathered surface. On metal, the mark might be nothing more than a scuffed circle that shows under oblique light. When those rings appear in evenly spaced rows, and when the distance between rows and the diameter of rings match what's known from arms or clubs, the pattern is more than curiosity. It's a signature. The beak is the business end, and its shape answers many questions. While a live animal keeps that beak under a crown of arms, a beak once freed from muscle survives like a coin tossed into a box of sand. Its upper and lower halves meet in a curved edge that closes with scissors-like action. Beak size scales with animal size. Where shows diet, softer prey, smooth edges, tougher prey, scuffs them differently. Layers in the beak, built as the animal grows, trap tiny chemical clues tied to water masses with slightly different compositions. When scientists examine multiple beaks from a region, the set can tell a story about where the animals fed, not just what they ate. In whale stomachs, beaks pile up. Size classes there show what the whales found. Across oceans, similar size classes suggest similar prey fields and similar ranges for the giants that supply those beaks. Eyes deserve another calm spotlight, because they connect the legend's gaze to a world built of faint contrasts. Deep water reduces light to a soft language. A broad pupil collects as many photons as possible. A large lens focuses. A retina tuned for changes in brightness notices silhouettes. In a camera clip, a crescent of eye edge sometimes reflects gently, the way a shoreline might reflect a low moon. A sailor who saw that curve once wrote that a lamp looked from under the arms. The phrase reads like poetry on the page, but under a naturalist's light, it's simply a large eye reflecting a faint glow. The poetry survives. The biology explains. A gentle tutorial on seeing at sea helps future witnesses describe better. The mind loves one big object more than several small ones. On moving water, it combines separate pieces into a whole, a line of porpoises into a single long back, a scattered kelp mat into an animal that changes shape. To resist that habit, a witness can list separate parts, one pale line here, a second below it, both moving in the same direction. A round mark appeared on the hull later at this height. A dull smell like cleaner hung in the air. Those simple phrases contain more truth than 1,000 adjectives. They also carry comfortably in the ears of children and older adults, because they offer clear images instead of judgments. Whales re-enter the picture as teachers who never speak yet leave essays across their skin. Their scar patterns tell timing. Fresh rings cluster in a season, old ones spread across years. Their recordings tell place. Foraging clicks cluster in certain canyons at certain hours, suggesting where squids and other prey gather. The link between whales and giants leaves a practical lesson. The surest way to meet a hidden animal is often to watch the one that hunts it. In that sense, the longest-running survey in the Kraken story belongs to whales that have been riding on themselves for lifetimes. Now, because numbers help soften old fears, a friendly calculation draws a line under the question of ships and arms. A medium fishing vessel, with a freeboard of 2 meters, would require an animal to lift much of its own body to reach a rail. Suckers function best when fully sealed against smooth surfaces. A rail's edges and fittings break those seals quickly. The area and pressure of many cups together can hold a large fish against motion in water. It does not sum to a force that drags a vessel down against buoyancy designed to carry many tons. Occasional nuisance. Yes, lines tugged, bait bags explored. A moment of surprise at the rail. Intentional sinking. No, the math leaves wonder intact while setting boundaries that keep the story honest. Case reports. Let the story practice this honesty. A shrimper records a pre-dawn visit, when a pale length glided in like a cautious cat, touched a bag of fish heads twice, and dissolved into blackness. The camera caught the essence. A club opening and closing, with that distinctive fan-like motion. A mantle outline. The brief, perfect circle of a sucker ring under red light. Coordinates, depth, and current speed went into the margins. A week later, eDNA from nearby water bottles returned a giant squid signature. The pair image and DNA formed a simple, strong link. In another case, sailors tied to a mooring found faint, round scuffs on a fresh coat of hull paint in the morning. They circled 4 that were clear and measured the spacing. The spacing matched an arm row. A single ring measured larger than a $50. The marina's quiet became a classroom for anyone willing to peer at the waterline and imagine slow, curious arms that left in the night with nothing broken and everything answered. Education in museums and aquariums makes those lessons stick. A child places a finger inside a replica sucker ring and feels the tiny serrations under the pad of a fingertip. An adult tries to open a sturdy model beak and feels the levered power designed for seafood, not steel. A visitor stands before a giant eye model in a dim room with a single dot of light far away and sees how a large lens makes small light useful. A hull panel holds real, rubbed-in circles collected from an old wooden boat and framed like prints. These simple contacts turn the Kraken from a shadow into a neighbor. They also equip viewers with the right vocabulary: ring, club, beak, mantle, fin. When those viewers watch footage online later, they recognize what they see and share it with better words. A small mailbag of common questions earns quick, clear answers without rushing. Do large squids attack lights? They sometimes approach lights out of curiosity or because prey gathers there. Harsh beams often push them away. Soft red light allows longer, calmer views. How deep do they live? Most spend time hundreds to 1,000 meters down, visiting shallower water at night, when small life rises or when injury and illness pull them up. Why are they rarely seen? The deep is enormous, cameras are few, and short encounters pass by, unless a patient eye waits in the right place. Are humans at risk? Divers may face danger if entangled with gear and a large animal nearby. Intentional harm from giants is not a pattern. Are there supergiants beyond known sizes? Outliers exist in biology, but the most reliable records cluster around sizes that, while enormous, stop well short of the wildest poster art. Each answer favors plain words over drama and leaves room for new finding. With the how of encounters and the what of parts clear, the script drifts over the where, with a map reader's calm. See amounts. Submerged mountains that rise from the deep and do not break the surface, cause upwelling that brings nutrients toward light. Life stacks there, like a crowd at a market stall. Continental shelf edges act like avenues, guiding currents along drop-offs. Canyons cut those shelves like streets, directing flows up and down between shallow and deep layers. Convergence zones form where waters of different temperatures and salinities meet. Along those fronts, floating life concentrates, and so do the things that eat it. A person standing on a pier sees only a flat surface that changes with wind. A person holding a chart of depth and current sees a city plan. Giants prefer the city over the empty lot. The toolset now in hand lets modest boats behave like observatories. DNA bottles, labeled by depth and time, gather traces in a few minutes. Passive acoustic recorders, the size of a thermos, listen for whale clicks that speed up when hunting happens. Low-light cameras sit on frames that weigh little and deploy easily. Red illumination keeps scenes calm. A single night's work along a canyon's edge can produce a line of data points that, placed on a map, draw a shape of life. If nothing shows, that absence becomes a fact rather than a rumor. A night when whales fed elsewhere, a layer where giants didn't pass. Publishing such nights keeps everyone's expectations clean. When future witnesses contribute, a gentle form helps. Describe what was seen first, second, and third. Draw the distances with your hand on the photo if helpful. Note a smell. Note the height of any marks on the hull. Write down wind, tide, moon. Estimate directions with simple words. Upstream, down canyon, toward the headland. This kind of checklist produces stories that survive outside the teller's circle and help everyone afterward. It also makes older accounts easier to translate because the same elements, order, distance, smell, direction, appear across centuries. Growth and life cycle re-enter with a few friendly observations. A hatchling's world is one of hiding in food, because in the ocean, the safest place for a small animal is inside the crowded layer where many small animals live. As the squid grows, it moves through the water column, finding the balance between energy spent and energy gained that suits its build. A large, powerful adult needs fewer meals than the small one did, but those meals must be efficient. That is where the tentacle clubs shine. They extend beyond the arms, reducing the time between seeing prey and touching it. A quick lunge, a solid grip, a fold inward, a beak's bite, and the jet pulses again to resume position. Seen in good light, the motion reads as practiced economy, not frenzy. Differences between giant and colossal squids become useful when reading certain marks and movements. Hooks on the colossal's arms and tentacles can leave punctures in soft tissue that differ from smooth rings. A heavier build produces a steadier hover in rougher water, less swaying, more planted presence. The colossal's eyes, at the outer edge of what animals build, make sense in a theater where whales move like dark moons, and where the glow of other creatures allows outlines to be detected at distances that give an ambush hunter a small head start. The giant's design, a touch sleeker, suits more open pursuit, nonetheless tempered by the limits of water. A practical interlude explains why ammonium salts drift into so many scenes. Many squids adjust buoyancy using ammonium-rich fluids in their tissues. That chemical choice is lighter than seawater and helps them float with less effort at depth. Near the surface where temperature and chemistry differ, ammonia can become noticeable. A faint scent on a deck hand, a sharper scent near washed-up tissue, a note in a log that the air smelled like a cleaning cupboard. These small details point back to a living system that swaps bone for buoyancy fluid to manage life in the pressure of the deep. Cameras handle all this best when they respect the animal's senses. Low, even light in the red part of the spectrum keeps the scene gentle. Bait is secured so it does not spin wildly and alarm the visitor. Frames are quiet in the water so they do not hum in a way that discourages approach. The best positions face slightly upward because many deep animals look up for silhouettes and rise to investigate. A clean frame with a scale bar in view turns a curious pass into a new measurement. When that pass is recorded without stress, the behavior captured likely reflects real life rather than a reaction to a surprise. Machine vision deserves one more minute because it works well in the dark. Hours of video can be analyzed for characteristic motions. The wave of a fin with a certain rhythm, the opening pattern of a tentacle club, the circular flashes of sucker rings as they orient to press. Models trained on known clips can flag frames where such patterns repeat. A human then reviews a short list. This doesn't make machines the discoverers, it makes them tireless assistants who never blink. In a world where data piles up faster than eyes can screen it, such help keeps important seconds from being lost. Ocean Change returns with a useful point. The giant's postal routes can move. If warmer layers cap a region, pushing oxygen lower, prey may choose different nights or different depths for their daily migrations. Giants may follow. Strandings might cluster a month earlier or later than they once did. Whale foraging clicks may concentrate in different canyons. Attention can keep up. Communities that collect the same kinds of notes over years, moon phase, tide, layer depth, presence of rings on whales, will see patterns shift and will be able to say how, not just that, things changed. Lookalikes sometimes fool even careful eyes. So the script offers a pocket guide anyone can keep. Oarfish undulate side to side and have a distinct dorsal crest. Their motion is ribbon-like and smooth. Jellyfish push water in pulses and lack the structured aim of a muscular arm. Their edges wobble and they drift with currents, rather than choosing direction confidently. Kelp wraps and drifts. It does not press and release with decision. Whale fins have rigid leading edges. Arms do not. If circles appear obviously in rows, if a faint ammonia scent hangs in the air, if a beak fragment is found nearby, the evidence leans strongly toward squid. Without those, a polite could-be remains wise. One last friendly glance at engineering and ship rails leaves everyone with numbers they can imagine without math. A tentacle club reaching 1.5 meters beyond the arms can feel like a rope over a handrail. A beak capable of slicing thick fish would be frightening if it were attached to an animal that sought boats. It is simply impressive when it belongs to a hunter that prefers deep, cold water and small, quick meals. The suction from a single large cup can hold a palm firmly. The multiply-applied suction of many cups can hold a body of similar scale during a hunt. That same system applied to a smooth hull for a moment can leave a row of neat-polished circles that a person can trace at dawn with the tips of their fingers. The scale, palms, rails, and rows keeps fear at bay and wonder alive. Stories from decks across oceans repeat the same simple choreography with regional flavors. In the North Atlantic, a crew anchored near a shelf edge hears small fish scatter in quick, heavy splashes that stop as soon as they start. A pale line rises into the transom light, turns and crosses back out of the beam, leaving the night unchanged. In the Pacific near an island arc, longliners pull up gear at sunup to find a tentacle ribbon snagged near a hook. The club shows large, evenly spaced suckers. The deck smells faintly. In the Southern Ocean, a research ship dodges brash ice, while a camera hangs over the side. A stout arm tests a bait bag and holds longer than most, then releases with no rush, the fin waving like a slow flag. The tails carry no panic. They carry the same handful of parts: touch, circle, scent, and silence after. Culture remains a helpful partner when it chooses accuracy over exaggeration. A children's book shows club pads with larger suckers at the end, and smaller ones along the arm rows. An exhibit places a whale jaw beside a cabinet of squid beaks. The contrast tells more than labels could. A film shows a beak where it belongs and keeps teeth out of a place where there are none. These gentle corrections do not drain excitement. They invite more viewers to stay because the world on screen and the world in the water rhyme. As the modern portrait grows complete, the giant reveal takes the shape of a tidy checklist. Scars on whales match sucker rings in size and spacing. Beaks in stomachs match those on beaches. Clubs in slow video match clubs in museums. eDNA samples match creatures believed to be in a region from other lines of evidence. Range maps match canyons where whales feed most. Behavior in calm footage matches the logic of a body plan built for long, steady holds, more than for sudden chaos. The result is not a single photograph on a wall. It is a shelf of labeled jars, images, and notes that together hold the story without the help of thunder. A final pass through quick facts feeds the last stretch before the conclusion begins to form. In the distance, quick fact: Even at large sizes, squids keep skin that can change color with chromatophores. But in the deep, those displays are less about communication and more about brief camouflage and stress responses. Quick fact: giant nerve axons exist not to be famous, but to speed signals to muscles in a world where milliseconds can decide whether a prey fish escapes. Quick fact: not all rings are created equal. On some species, serrations are more pronounced on certain arms, and those differences become a way to sort species even from small pieces. Quick fact: ammonia's scent is not a perfect marker. Other sources can produce it, but in the company of circles, clubs, and beaks, it strengthens, not weakens, an identification. The synthesis that follows is gentle, because everything needed is already on deck. The evidence tiers direct images at the top, remains in context below, indirect signs at the base stack, with a confidence that does not need to make predictions beyond their reach. Where cameras show arms and clubs near bait at depths whales hunt, and eDNA samples confirm a match, and whales carry fresh rings in the same season, the confidence that giants live and feed in that space is high. Where a beach holds a beak and arm pieces, confidence that the local ocean supports giants is high. Where only stories and scuffs appear, confidence is lower but not zero, and the advice becomes return with a bottle, a camera, and a scale. The ranked plan for where to learn most with the least risk and the greatest clarity floats to the top without a vote. Atlantic canyons that host repeated whale feeding events in predictable windows come first. The southern ocean's edges near ice lines where colossal squids likely hold court come next, with weather respected. Island arcs in the Pacific, where seamounts line up like beads on a string, offer long-line platforms for small standardized camera rigs that can watch without interfering with work. Ports with engaged communities and nearby labs can serve as hubs where beach finds become labeled samples instead of rumors. Each place invites the same approach: patient, transparent, small tool science that any listener can understand. As the final arc approaches, the script holds the closing shape in view without rushing to it. The verdict will be calm. The Kraken is not one beast, but a set of very large squids, whose parts and behaviors explain the old marks and present-day meetings. The single, most testable next step will be specific: a canyon campaign that marries eDNA, passive acoustics, and gentle low-light cameras during the exact windows when whales sprint their clicks and prey rises. The farewell will widen the view, an ocean that keeps files and shares them with steady hands, a world where fear can retire and attention can take its place. The modern portrait grows clearer as each quiet piece finds its place on the shelf. Scars on whales write in circles, beaks on beaches keep their ink-black curves, clubs on camera unfold like careful fans, water in small bottles carries traces that match those faces, and routes on maps align with canyons and fronts, where prey gathers like grain in a winnowed field. The picture that emerges is steady, not theatrical, a sleek giant that holds position with small fin waves and jet pulses, striking with two extended clubs, drawing prey in and resuming a hover, and a heavier cousin that waits in colder rooms, hooks ready, eyes wide for the faintest motion. Both share the tools that made sailors' notebooks honest: suckers that print rings, arms that feel like ropes, mantle humps that rise and vanish without a dorsal fin to frame the moment, and a faint ammonia scent that lingers on a hand. Legends inflated the scale. Technology now restores proportions without removing wonder. Let's go step by step through the final connections that turn scattered evidence into one living profile. First, timing. Whales mark the hours. Their foraging clicks quicken in certain canyons shortly after sunset. The rush of small life toward the surface builds a staircase of opportunity, and more meetings between giants and whales occur in those windows than at noon. Second, place. Bathymetry predicts chance. Where a continental shelf ends in a sharp drop and a canyon reaches landward like a finger, Currents thread food up and down that edge, and giants hold there to meet it. Third, behavior. Calm clips under red light show arms exploring and clubs pressing with a measured rhythm, not the frantic flailing that posters love. Fourth, identity. DNA and anatomy link the scene to a species without guesswork. When all four timing, place, behavior, identity stand together in a single night's notes, the file reads like a quiet confession from the sea. A few field stories, collected from different oceans and decades, anchor the method in scenes that anyone can imagine. In the far North Atlantic, a research crew working a shelf break sets 4 stations along a line that runs from 300 meters deep to 900 meters and leaves them overnight. At dawn, they recover their cameras. 3 hold only small fish and a passing lantern-eyed visitor. The second deepest shows a deliberate approach. A pale club opens, presses and reveals the neat pattern of large suckers at its end. An arm alongside shows smaller suckers in rows with even spacing. The fin on the mantle draws a low, even wave. The eye's cut edge flashes a crescent. As it turns, a bottle sample taken from the same depth at the same hour carries a genetic signature that matches the animal in view. Later, a local whale seen that morning bears fresh, small rings high on the head. None of these pieces alone would satisfy a careful mind. Altogether, they sit like matched stones in a wall. In the subtropical Pacific near an island arc, longline fishers haul gear before sunrise and find a strip of tentacle club wrapped near a terminal hook, torn cleanly along a line. The deck smells faintly sharp. On a marked board, the crew sets the strip and takes a clear, square photo with the sun behind their backs, so shadows don't lie. The sucker rings, still stiff, show serrations under handheld magnification. The photo goes to a shoreside lab with coordinates and depth. The lab confirms species-level identity from ring pattern alone, and later from a small tissue swab, preserved in alcohol. On the map, a month later, that photo anchors a point on a route that bends between 2 cinemounts, an empty space made legible by one measured image. On a gray beach in the Southern Ocean, hikers stop at a tangle of pale tissue caught among kelp. They see a black curved plate, hard and shiny, set like a parrot's beak without a face. The smell argues for squid. A park warden arrives, takes a small section from the edge, and photographs the beak beside a ruler that begins at 0, not at a chip. In a museum workshop down the coast, a curator compares the beak to catalog specimens, measures key angles, and records an estimate of the animal's size. The ring of serrations on a nearby sucker fragment matches the guess. That day's rough surf and wind did not allow cameras in the water. Nevertheless, the shore delivered a clean lesson for anyone willing to kneel and look closely. There is also value in the calm dismantling of a misread, because practice with errors sharpens future eyes. After a storm, a long fibrous mass washes ashore and turns heads. Photos circulate fast, claiming a massive octopus carcass. At low tide, a biologist and a park steward approach the mass with clear minds. The fibers align along tracks that match decomposing connective tissue from a whale, not smooth muscular arms. There are no true sucker rings, only dimples in decaying flesh. There is no beak, no club. The finding is logged as whale remains with a note that explains why it fooled phones at first glance. This sort of corrective does not scold. It models patience and leaves the public better prepared. The last drift through anatomy, now that the viewer knows the cast, emphasizes what marks matter. Arms carry many small suckers in ordered rows. Tentacle clubs carry larger suckers toward their ends, often in different arrangements. The largest rings leave rings big enough to sit under a child's palm. Keratin-like teeth on those rings cut perfect circles into anything soft enough to receive them and buff paint into tidy halos. Hooks on some species turn smooth circles into punctures and tears, a difference that shows up cleanly in good photos. Beaks carry life story in their layers even when separated from flesh. They link to size and through subtle chemistry hint at the water types the animal preferred. Eyes serve always a single purpose: to make dim moves legible. Their hugeness suits a narrow task and a narrow world. In that suit lies both their beauty and their explanation. Cephalopod intelligence remains a draw, and the last word on it is best given without drama. Arms possess local control circuits that allow them to sample, grasp, and adjust with grace even when a central brain is managing hover and watchfulness. Color waves across skin enable quick camouflage and communication. At depth, those waves likely play smaller roles than they do in bright shallows, but they persist, meaning stress or interest can pulse outward in visible ripples, especially near the surface at night. In calm footage, an arm may press 3 times with increasingly light touch, like a pianist practicing a phrase more softly each pass. That pattern seen across clips speaks of a nervous system designed to try, feel, and refine. Growth and lifespan offer one last sober frame. A giant becomes a giant in a handful of years, not decades. Fast growth, brief adulthood, and a singular reproductive effort likely lie behind many of the gaps in knowledge, because the ocean is skillful at hiding beginnings and endings. That brevity should invite careful study rather than rush. It also explains why strandings deliver few complete bodies. An animal that spends almost all of its time in cold, high-pressure rooms and dies there seldom rises in one piece to a beach. Hunting style closes with a double picture that suits cook and classroom alike. Imagine 2 kitchens. In one, a chef waits at a counter with a sharp knife, reaching out with long tongs only when a dish arrives within arm's length. Clean motions, few steps, precise cuts. In the other, a chef moves across the space more freely, still precise but with more travel between stations. Both make good meals. Both conserve energy for the hardest moments. The colossal fits the first kitchen, the giant the second. Prey is the same. Quick fish, smaller squids, things that can be gripped with circles and brought under a beak. That domestic image holds because it respects the energy math at depth. Elegance is efficiency. Habitat, tools, and the public can now meet in a plan that anyone can picture. Along a canyon known for whale dives, small vessels spaced safely apart deploy low-light cameras on clean frames at 3 depths: the top of the canyon wall, the mid-slope, and the deep floor. Each frame includes a fixed scale bar. Each carries a small secure bait bag and a current meter that writes direction and speed. At the same time, simple bottle samplers collect water near each frame. Passive acoustic recorders sit on the bottom, listening for the tempo of whale hunts. The array stays for 3 nights, bracketing a new moon. Back ashore, eDNA is read. Audio is scanned for click bursts. Video is screened by machine, then by human eyes. A quiet, complete report follows. Film, maps, sound, DNA released without hype. If arms arrived, the frames tell where and when. If only whales fed, the sound tells why arms may have stayed out of range. If nothing came, that too enters the public log as an honest night. Quick fact: this kind of array works for schools and community groups as well as for science teams. A coastal class can pair with a lab, borrow a frame and a recorder, and adopt a canyon edge for a season. Students can fill out witness forms when they meet circles on a hull or find a beak on a beach walk. A fisherman can carry a laminated scale board and a sample vial for rare mornings when a ring holds or a strip appears. Small habits like these turn a coastline into a network that hears the deep with many ears. Ocean change hovers in the background, like weather, warm caps, thinning oxygen layers, shifts in front positions, all adjust the lanes. Giants may climb higher on some nights or lower in some seasons. Whales may move canyons. Strandings might jump a month on the calendar. A long memory kept in shared dents can tell that story without making it frightening. The ocean has always moved. Now it moves with new patterns. Knowing those patterns turns worry into watchfulness. Lookalikes, reintroduced now as a public service. Ask for one firm habit. Check for structure. Arms have brains in them, so to speak. They choose. Kelp does not. Jellyfish pulse, but cannot aim. Oarfish bend in long, continuous waves. Squids press with discrete limbs. Whale fins are rigid. Arms are supple. If circles appear, and if they sit in clean rows, the case strengthens. If an odor drifts that suggests ammonia and a beak lies nearby, the case hardens further. A photograph with a scale, not a guess in a caption. A scale in the frame turns suspicion into something shareable. Senses in the abyss deserve a final nod, because they shape the animals into what they are. Large eyes are not exaggerations. They are tools matched to a world where a small increase in light capture can double the distance at which a predator sees prey, or a prey sees danger. Rows of suckers are not decoration. They are touch and taste organs that instantly report texture and chemistry to nerve centers along each arm. Fins and jet are not redundant. One does steady, the other does sprint. When all of that is filmed at a respectful distance, the audience sees the solution to a problem rather than a threat to a ship. Engineering at human scale ends with a few images that stay in a viewer's pocket. A ring big enough to frame a child's palm. A club long enough to reach across a kitchen table. A fin that moves like a slow flag. A beak that could slice a thick fish fillet cleanly. An eye as wide as a dinner plate, because darkness requires a dish, not a thimble. None of that asks the viewer to imagine giants beyond measure. It asks only for attention to a real, impressive size that shares the sea with ships and whales, but chooses different rooms. Stories from boats stitch continents together. A trawler in cool water feels a line go tight and then slacken. A spoon handle frees a ring. A phone captures the moment against a marked board. A sailboat in warm water sees a pale line pass a stern light. Morning shows circles at the paint line. A water bottle dipped carefully by the mark later tells its secret to a lab. A research ship among ice pans sees a sturdy arm test a bag, hold and let go without tearing. A beak on a beach weeks later completes the puzzle for a child who visited both scenes in a school program. Nothing in these scenes shouts, everything in them teaches. Culture shares responsibility for what minds expect to see next. A filmmaker who places the beak under the arms and draws rings in rows does more for the public's understanding than 100 roaring battles. A museum that lets visitors touch a replica ring and a rubbed hull panel gives them a feeling that words cannot replace. A picture book that shows a mantle hump without a dorsal fin near the surface plants a seed of accuracy. These acts do not drain romance, they tune it. The giant reveal, promised at the start, now lands without trumpets. The image of a ship, wrapped and dragged toward a vortex, yields to a patient, truer picture. A deep-dwelling hunter, with eyes built for faint light, arms that print circles on whales, clubs that reach, a beak that cuts fish, and a body that holds steadiness with fins and jet. The colossal lives farther south, heavier and hooked, closer to ice edges. The giant ranges more widely, sleeker, with rings for grip. Both can touch a hull, neither can sink one. Both exist in numbers sufficient to feed whales. Neither appears often enough to the human eye to become ordinary. A viewer can carry this picture into any harbor and see signs with better questions. Synthesis is simple now, because each tier of evidence has earned its role. Tier 1, close, calm video of living animals in their world, answers questions of behavior, body plan, and scale at once. Tier 2 remains in context, answers questions of identity and size, sometimes of diet and age, and gives museums what they need to teach. Tier 3, indirect signs such as scars, hull circles, and eDNA, answers questions of presence and timing and directs cameras where to look. Confidence sits highest where all three tiers overlap and narrows gracefully where only one appears. This keeps speech honest and directs attention where it yields most. The fieldwork wish list, arranged like a recipe card, concludes the practical part. Choose 3 canyons with reliable whale feeding seasons. In each, Set a line of 3 stations: shelf edge, mid-slope, deep floor. Equipped with low-light cameras, bait sacks tied tight against spinning, fixed-scale bars in frame, current meters, and bottle samplers. Add 1 passive acoustic recorder per canyon. Work a 3-night window around a new moon in 2 seasons. Publish a pre-plan so crews and communities can follow along. Release complete results, including nights with no approaches, and include raw stills of any rings, clubs, and beaks with scale. Pair with a simple public witness form that any fisher or sailor can download and use. Invite schools to adopt a station and help annotate video. This is small science in service of a large curiosity, and it is enough. With the craft established, the conclusion arrives on a level keel. The verdict is clear and calm. The Kraken of story maps onto real giants of the deep. Giant squids and colossal squids, magnificent animals, whose eyes, arms, clubs, rings, beaks, and habits explain the marks on whales, the circles on hulls, the glimpses by lantern light, and the faint, clean smell left on a deckhand's fingers. They are not villains. They are neighbors with jobs in a food web that ties the surface to the seafloor. The single next test that would settle open questions is specific and immediate. It is a coordinated canyon campaign that combines environmental DNA, passive acoustic listening, and gentle low-light video during those precise windows when whales increase their hunting clicks and midwater animals climb. The campaign would place cameras at fixed depths with scale in frame, sample water in matching intervals, and log current and light carefully. The results, shared fully, would tell how often giants approach certain depths, at what hours, and in what company. Such knowledge would turn many maybe sightings into most likely, and would let future storytellers speak with fewer hedges. To widen the lens before goodbye, the narrator returns to the ocean itself. The sea keeps files. It stores rings on whales and beaks in stomachs. It keeps clubs in nets and beaks on beaches for careful hands to find. It allows cameras to borrow a minute of true behavior under soft light, and permits a bottle of water to carry a signature up a rope. People who move slowly and record plainly can read those files and share them. The trade offered tonight is simple. Replace fear with attention. Replace posters with patient images. Replace arguments between friends with shared notes that anyone can check. A gentle farewell fits a story about patience. Evening settles. A boy dips once and rises. A whale's breath knots and disappears. A lighthouse ticks like a metronome beyond the jetty. Somewhere below a quiet bay, 2 long tentacles hang in a question mark, and arms adjust a hover that looks like rest, but is only readiness. A camera in the dark might be waiting there with a small red glow, and a steel bar in frame to set scale for the future. The ocean will decide whether to show anything tonight. If it does, the next shelf in the library will fill. If it does not, the ledger will add a page that keeps the map honest. The last line returns the legend to its rightful place. The Kraken was never one animal in one pose. It was a bundle of signs carried across time by sailors who looked closely and wrote plainly. Circles on skin, ropes that were alive, hills of water without wind, a pale glint under arms, and a smell that lingered for a minute. Science did not extinguish that bundle. It sorted it. The result is smaller than a myth and larger than a rumor. It is a living portrait, a giant that hunts by touch and faint light in a deep blue room, and a heavier cousin that waits in colder halls. Both worth meeting with a steady gaze and a notebook that leaves out nothing and adds nothing that isn't there.